what do we need to solve a differential equation exactly? We need, if it's a differential equation such as the one on top, we need its initial conditions because there is a time derivative here, like how does the system begin with? And then we have something called the boundary conditions, like how the system behaves in the edges. So this is in what? The space varies in x and y, so we need two boundary conditions, one in x and one in y, and then we need an initial condition because we have a time derivative. So all of this has to be supplied to the equation before solving it. And so how does the initial conditions look like? The initial condition is nothing but, as I mentioned initially, that at first the initial concentration of the system is like, it's all mixed at a particular concentration. So if we have a system here in the box, which is denoted by this, it is going to be homogeneously distributed, like at each point there will be some amount of A and some amount of B. So that's my initial condition. Now the boundary conditions here are a bit nuanced because what you're going to do is follow periodic boundary condition. What are those? Now in general physics, it is also known as the von Karman boundary conditions, where now in a computer we cannot simulate this entire table or this actual system size, because then we're gonna die. Like there is no computing power in this world which can do that. So we do a very small size, a representative element of a very small length scale. But the problems then is surfaces, because the system in general in any physical condition changes a lot when surfaces are involved. Why? Because every system is made out of atoms which bond with each other. So inside the system we have an atom which is bonded to like 4 its nearest atoms. But the same atom at the edge will have one bond missing over here. So modeling surfaces is a big mess, because like it's a mess in general, but in this particular case we really don't want to deal with surfaces. We want to simulate bulk properties of a system, and for that the trick involved is called the periodic boundary condition, where if you remember in the finite difference scheme, we needed the values at the left